Welcome class 10. Today we are going to start with chapter 10, electromagnetism. And today's topic is Oersted's experiment on the magnetic effect of electric current. So, Hans Christian Oersted was a Danish scientist who also discovered aluminium. In 1820, he discovered the magnetic effect of electric current. So, in his experiment, he found out that when the current passes through the wire and if the magnetic needle or a compass is kept near the wire in which the current is flowing, then there would be a deflection in the magnetic needle, and this magnetic needle would deflect in a particular direction. So let's understand about this in more detail. So when the wire was connected through a source of current, that is the battery over here, and when the switch was kept open, that means when the switch was off, the magnetic needle would show no deflection. So over here, this magnetic needle is showing the north N, that is the magnetic north, that is the Earth's magnetic north. So when there is no current flowing through, it shows the Earth's magnetic north. But as soon as the current starts flowing, or when the switch is kept closed or on, then the magnetic needle shows some deflection. This is because when the current flows through the wire, some electric field is generated around the wire, when the current flows, and because of that magnetic field, the magnetic needle shows the deflection. In the next step, when the direction of the current is changed, that is when the when the terminal of the wires are changed, the positive is made negative and the negative is changed to positive, then the current starts flowing in the reverse direction. And when the current flows in the reverse direction, we observe that the magnetic needle also deflects in the opposite direction. Previously, the north was pointing in that direction, and now when the current direction is reversed, the magnetic needle also shows the reversed direction, that is, it points towards the opposite direction. So this is because of the magnetic field generated by the electric current. So the conclusions that we arrive at is the deflection of magnetic needle on passing electric current in the wire indicates the creation of magnetic field around the wire. The magnetic needle of compass experiences a force, so it deflects to align itself in the direction of magnetic field at that point. On increasing current in the wire, the deflection of the compass needle increases, which implies that the strength of magnetic field around the wire also increases. And on reversing the direction of current in the wire, the direction of deflection of the compass needle reverses, which implies that the direction of the magnetic field around the wire also reverses. So when this magnetic needle or compass is taken away from the wire, as shown in the picture over here, it was kept over here and it showed some deflection. Now when this compass is moved away from the wire and still the wire has the flow of current, then we observe that the deflection in the magnetic needle is reduced. So as the magnetic needle is moved away from the wire, the deflection gets the strength of the deflection gets reduced, and from a certain point it will stop deflecting at all. So this is because the magnetic field across the wire also gets its strength reduced as it moves away from the wire. So we can say that on increasing the distance between the wire and the magnetic needle, the deflection of the compass needle decreases, which implies that the strength of the magnetic field around the wire decreases while moving away from the wire. So the inference of this video is that an electric current produces a magnetic field around the wire. This is called the magnetic effect of current. And the strength of magnetic field depends on the magnitude of current, and its direction depends on the direction of current. So this is all about the magnetic field because of the electric current. Thank you.